example of mean value theorems as well as differentiabilities. So in the last class we have already discussed about limits. What are limits? We had also discussed about continuity. There is one more agenda, or the next point which you can say is something called as differentiability. Right? Now this is a very important aspect sometimes, because the function is differentiable or it is not, right? Or sometimes it is asked whether it is continuous or not, right? So you have to understand this particular thing. Differentiability means whether the function is differentiable or not, you are trying to say. So in a one line, if I will say whether you are to check a differentiability or not, you just find out, for example, whatever function is given to you. Question is being asked, whether this is continuous or not, whether this function is continuous. Your options will be something like, continuous, not differentiable, continuous, differentiable, not continuous, differentiable, not continuous, not differentiable, something like this. So what we have to choose for continuity, we know that left hand limit should be equal to right hand limit should be equal to the function value itself. That is for continuity, right? For differentiability, whether this function will be differentiable or not, you just check it out. Find out the f dash x. Now if f dash x is not continuous, if f dash x is not continuous, then you can say fx is not differentiable. At that point, in a very simple language, what I'm trying to say is, find out f dash x. If f dash x is not continuous, then fx is not differentiable at that point, right? What I mean to say by this particular thing, we'll explain it something like in an example. What is example we are going to take is, let us say fx is equals to modulus of x. Let us take a fresh page for this particular thing. Let us say fx is equals to modulus of x. You have to check whether this is a continuous function or not, right? You have to check whether this is a continuous function or not, right? So what I will say is, if you see the graph of this, what is modulus x graph? Something like this, right? And you have to check this at x equals to 0. So for continuity, what I will say very simply, limit x tends to 0 minus, what will the function like for 0 minus? Fx should be equal to limit x tends to 0 plus of fx, and should be equal to f of 0. This is going to be same, then the function is continuous in nature, right? So if I put this point, limit h tends to 0, it is 0 minus h modulus, is it equal to limit h tends to 0, 0 plus h modulus is equals to modulus of 0. So if I say this is minus 0 or 0, whatever it is, so it is 0 equal to 0 equal to 0. So yes, we can say, so the function fx is continuous at x equals to 0, right? Now for the second case, when you're talking about differentiability, so for differentiability, what I said was, check whether the f dash x is continuous. So what is fx? Fx is modulus of x. Can I say that? We can say that fx is nothing but, if I split, this will be x for x greater than equal to 0. This will be equal to minus x for x less than 0, isn't it? Right? So if I find f dash x for differentiability, let us find out f dash of x. F dash of x will become what? 1 for x greater than or equal to 0, minus 1 for x less than 0. Now if I plot this f dash of x, let's say this is the origin. If I am plotting this, you will find that this is 1. This is 1, right, for x greater than or equal to 0. And this is equal to minus 1 for x less than 0. Is it continuous at x equal to 0? No. There is a amount of discontinuity, you can see. There is amount of discontinuity, we can see. So we will say that as the f dash x is discontinuous at x equal to 0, the function fx is not differentiable at x equal to 0. Clear? This is a very simple fundamental which you can solve. Let us take a problem from GATE paper. Question came in GATE 2010. The question was, the function y is equals to 2 minus 3x is, question options were continuous and differentiable for all r is representing set of real numbers. Second, continuous for all r but not differentiable at 3/2. Continuous for all r but not differentiable at 2/3. Continuous for all r, or you can say discontinuous at x equal to 2/3 but differentiable for all r. Simply, what should be your answer? Yes, very correct. It should be continuous for all r but not differentiable at x equal to 2/3. Because at that point the f dash x will be discontinuous. The f dash x will be discontinuous. If you want the solution, you can very easily find out it is nothing but 2 minus 3x, right? So this can be written as, the function can be written as 2 minus 3x for x greater than equal to 0, and is minus of 2 minus 3x for x less than 0, right? So if I differentiate, what will I get? Y dash will give me minus 3 and this will give me 3 for x greater than equal to 0, x less than equal to 0, right? So you can easily identify that particular thing. Now in that particular thing we will say that this is not, in fact x is basically 2 by 3, not 0, x 2 by 3, right? So there's a function which is discontinuous at 2 by 3. Y dash is discontinuous. So as y dash is discontinuous at x equals to 2 by 3, we can say it will be not differentiable at x equal to 2 by 3. Not it we will say, but we will say phi will be, right? So understood the difference between continuity and differentiabilities. So in this session we'll keep ourselves limited to this area. We'll discuss about mean values theorems in the next class. Thank you.